Alrighty, everyone. Happy Wednesday and welcome to the latest Spearbit seminar. I'm Spencer from the Spearbit team, and we are honored to have Gustavo Grieco from Trail of Bits. Gustavo is going to be giving a seminar on fuzzing, specifically the Echidna tool that Trail of Bits spearheads the development of. So, Gustavo, thank you very much for coming by, and I'll pass the mic to you.
Thank you. Thank you for the possibility of present our tool. We are going to start with the presentation. So I'm used to the Google Meet sharing screen. So if you can't see or if it's not correct or if the volume is too low or whatever, just let me know immediately so I can change it. Awesome. All right. I'm guessing everyone can see the screen, right?
We got you.
Okay. Awesome. Okay. So let's start with this presentation. So before starting a little bit about the company. So Spearbit is a security company that deals with different type of security issues. We do audits, we do research, we do engineer. We're not specifically a blockchain company, but a part of the team, the blockchain team, has dedicated the last 4 to 5 years to find issues in smart contracts and to build tools. So yeah, that was a very short introduction to the company. All right, so what we are going to do today. So in this hour, I want to do mainly two things. Understand what is fuzzing and why it's important, and a theoretical introduction to Echidna, which is our smart contract fuzzer tool. Also the second part will be dedicated to kind of an interactive session on the use of Echidna. That is something that it was one request from several users. So users want video tutorials and want to be able to engage, to participate, and to have questions. So the second part will be dedicated to that, and we will see how far we get according to the answers that you have, the ideas that you have on testing a very simple code. So we are going to work on that, and we're going to run a few short campaigns and iterate over the results. All right. So let's start with an introduction. So the first thing that you need to know is that for any type of testing, you need to know what are the type of what are the things that we are testing, right? And it will be very, very difficult if you start writing your smart contract or any type of system, and you don't know what it's supposed to be doing. So the first step for everything we're going to talk is to know exactly what your system should do and exactly when. So there are many ways to specify what you expect from a system. Usually one recommendation that we give is to think in smart contracts or all other type of program as state machines. So you have user interacting with your smart contract. They do some transaction, they make some operation, and they change the state. So I just show this example from a paper. It doesn't really matter what it's showing, but it basically shows that a smart contract has different states, and you can call operations to move from one state to another according to some condition. So the important part here is you should know what your system is doing. Otherwise, everything that comes in this presentation will not be really useful because you're not going to know what you're supposed to be testing. All right. With this clarification, let's take a quick look to what is the smart contract security, the state of the security nowadays. So I'm not explaining what smart contract is. I think That's more or less what we expect from someone joining. I know that some people are start with the development, so even if you are starting with the development, it should be fine to understand the code, the Solidity code that we're going to show. So so what is security in a smart contract? So we need to know what when a state is a bad state. If you have a token, an RC20 token, for instance, a bad state in your contract is one state in which one user managed to grab a token from another user, right, without actually allowing. And what we also want to know is what inputs, what transactions will lead to this bad behavior. We have some tools, and there are some tools that will say, well, there is a bad state in your smart contract, but it won't tell you how to get it. But it won't tell you if there is even a possibility of getting that. So we are going to take a look at that. So let's take an overview of some solutions. So the first possibility is to have no restrictions at all in the system in a smart contract. So everything can happen, and doesn't have any constraints, and basically you are it's a disaster waiting to happen, because a user or a potential attacker can find a way to force your smart contract to do something unexpected. So that's a step zero, and sadly we still see some code that is in such state. So one thing that it's a tool to deal with this is to have a programming language that allows to restrict the inputs. So, and in order to restrict inputs, we have things like types, we have privileges, we have roles. We can also remove code that is useless, or we can simplify code. And in the case of Ethereum smart contracts, we always wish that Solidity will help us to restrict the inputs in a way that will make our contracts better and more secure. But sadly, it's not always the case, and sometimes Solidity features can be misused. So yeah, definitely people should not rely just on the language to deal with the security. And the best way to deal is to have testing. So we have different type of testing. We're going to take a look into that. But I know a test basically will help to reduce and cover parts of the inputs that we have in the system. All right. So as I said, the first step when we see code that we need to evaluate in terms of security is developers that has no tests at all, and just wish or ask the developer not to add security issues in their smart contract. That, of course, is not the way to do it. So please don't consider, if you don't have tests at all, please consider that these approaches, it will never work. All right. So what is the next step? The next step is unit tests. So it's clear that a project with tests, it's much better than a project with no tests at all, right? And the unit test will basically kind of select a few points in the inputs of your system and make sure that these are covered. That these points, when these inputs, when you use them, when you make a transaction, they will return the actual the actual output that you expect. Of course, you cannot test extensively all your inputs because basically they have a very large input space, but however, it's still state of the art in terms of what you see on smart contract development today. But well, the idea of this presentation is to go beyond beyond unit test, and we're going to, but still we're going to start with that because that's something that usually developers know how to do. All right, and then we have phase two. In phase two, we have a tool that helps to helps with the testing and basically generates inputs in a way that we're going to discuss, and there are a few tools for that. Fuzzers are usually the more popular ones. There are other ones based on research technique like symbolic execution and some other tricks. But we're going to focus into fuzzers because they are starting to gain popularity and started to be essential part of the testing. So I'm seeing a question here. All right. All right. Should I turn off my camera, right?
Yeah, maybe that'll help.
Okay. Okay. Let me turn off camera. All right. I'm getting some distortion. This is perhaps someone. All right. Yeah. Now it's fine.
Yep, we're good
Great.
to go now.
Okay. Great. All right. So let's take a look to the actual buzzers that we have. Yeah, I'm still hearing the distort sound. Someone perhaps has sound. It's really annoying. Okay. Is it okay? All right. Yeah. Okay. Going back. So what is fuzzing? So this is the first thing. Um, so basically, with a fuzzer will generate some kind of random input, depending on how smart it is, can be more or less random. Then we will need a procedure to test something. We are going to go back into this, and basically then we check if the if the test failed or not. So this this looks like a very basic explanation, but it's actually useful to separate fuzzing from what we are actually testing, what we use for test in the middle. So that's why I'm highlighting this, because the rest usually doesn't depend on what you're testing. So you can change what you're testing with a different tool, and you can still get some interesting results. All right. So what we're going to test. So basically, so we can't. I know that most of the developer know unit test, but we can't use unit test directly. And the reason is simple. When we generate an input, a random input for our system, the unit test has already inputs that are fixed, right? So in the very simple example, we have this is even function that we test with the value 2, and the test is passing. However, if we're going to use this with a fuzzer, since we don't have a place to get to use the random input, then we we are just going to re-execute the same unit test over and over again. So we need something different. So what we need is a property. That why this is called property-based testing, right? So is fuzzing the same as property-based testing? Well, not exactly. So that's why we have two different things. We have the input generation, the random input generation, usually associated with fuzzers, and then the property-based testing, right? Which is something different that you can already do without actually using a fuzzer. So in this case, we have the is even function. We need to take what we have in the unit test and create something more general, more abstract, that allows to test with an input that is not fixed. And in this case, what we are going to use is we are going to use the same function, but instead of having a fixed parameter, we are going to put some number, some integer multiplied by 2. So, and perhaps one immediate question is, why not is even with the parameter n? So if you do that the with the range of let's say positive integers, there are going to be some inputs that are going to make the test fail, right? And you will need to know which ones are which which one should fail and which one should not, should return true or false, right? So basically, in this case, we are testing that the is even implementation is always returning true for this type of inputs. So we can make sure that it's working as expected. So we are not testing only one input, but we are testing a range of parameter. Let's say you can think as an infinite number of parameters, but in practice, of course, it's not infinite. So this is perhaps one key part of this presentation: how to take unit test and create a property. It's not always as simple as this one. We're going to see a more interesting example, but basically this is the idea. All right, let's go introducing Echidna. So what is Echidna? So Echidna is probably one of the first open source smart contract fuzzer for Ethereum. It's based on it's in Haskell using HVM, which is also used in other tools. It's going to use contract ABI, so you will need that, and it's focused on a couple of features. Let's say important design decisions. Should be easy to use. You should download it and run it with your smart contracts more or less as they are. It's optimized for short fuzzing campaigns, and it's also useful in your continuous integration test pipeline, so you can more or less easily integrate. We have a GitHub action for that. All right, so let's see a simple example with a very artificial invariant. We're going to see a more interesting example a little bit after I introduce the basic features. So in this example, we have a smart contract code that has two operations, set 0 and set 1, and has some state variables, and it has a function that we call invariant, that we are going to assert that it will never fail. It will never call the assert inside with a false. So Echidna will allow us to run through this in a fuzzing campaign and detect sequences of transactions that produce the invariant to fail with an assertion failure. So we're going to take a look of how that should run. So basically, you put the smart contract code when there is a single file. and we're going to use assertion mode. So Echidna has different ways to run. In this presentation, we are only going to show assertion mode, but there are a couple of other ways to use it. So after a few, let's say after 1 or 2 seconds, Echidna will find um, a list of transactions that will um, that will lead to a call to the invariant function that will trigger the assertion failure, right? And and after that, it will minimize. It will run what it calls a minimization procedure. So usually, Echidna will run with around 100 AVM transactions uh, with different, what the contract is supposed to be doing from the API perspective. So it will run set 0, set 1, and invariant in a random sequences of 100 transactions. At some point, it will it will check it will run invariant and will fail, and it will most likely have a very long sequence of transactions. However, only a few of them are useful for the actual um, test. So what the tool will do, and this is really important in order to debug what is going on, it will it will start reducing the list of transactions and check at every step if the invariant is still failing. If it's still failing, we'll keep reducing. If it's not failing, it will stop. So that will allow to shrink the input in order to get a shorter sequence of transactions. Um, and that will really help when you are doing the the debugging, trying to know what's going on. All right, so a little bit on what are how we can identify bad state in our smart contracts. So in Echidna, you define a target contract that is going to use for running running the transactions. There are different types of testing modes. We talk about assertion. There are Boolean properties in which you can encode something similar to this. So you can encode something like is even with a Boolean return value. But we are using a assertion here. For these examples are basically the same. Um, and and also one thing that is different from other tools is we don't have generic bug detectors, because on a smart contract it's better to know what are supposed to be doing than to have a generic way to detect things that probably will get false positives. For things like reentrancy, we have better tools. Tools like Slitter are going to be more effective finding reentrancy. Um, Integer overflows, you can find it with Echidna, but it's better to actually create a property that will fail if there is an integer overflow, because it will help the developer to think about the invariance of the system. So that's why we don't have any generic detectors. All right. So as I said, we have assertion modes, um, and any functions can contain asserts. The Solidity asserts, and it can trigger the assert either on the body of the function or in any internal functions. All right, so what people usually do when do this type of when do fuzzing in their smart contract. So basically, they start writing. So first, they need to know where are the invariants. This is step 0. Um, but they start writing the invariants in Solidity and run a short fuzzing campaign. And then they will check the results, and if there's something unexpected, they will keep iterating into that. So basically, they check invariants, they check pre and post conditions to know um, if that's something that they expect. If invariant is failing, why is failing? Is it failing because I forgot to add some something, or I'm adding something that is incorrect, some condition or something, or some piece of code. And also another important part is to monitor that a fuzzer can reach the state of your contract, or if you want to simplify a little bit, the lines in your code, right? And that's why. So in order to divide a little bit of what's happening inside Echidna, or in general, Ethereum smart contract, we have events. So what is support? What the support that we have for Echidna is events on the invariant function. So we can define an event with any um, with any number of parameters and any type of parameters, and we can emit the events. And in the case of a failure, the events will appear in the log. So let's take a look how it looks. So Echidna found that panic is a special event that comes from Solidity. That means there is an assertion failure. And then we have the values, the events that we added, so we can easily know what is going on inside the AVM. All right. Another thing that I was talking about was coverage. So we want to know if Echidna can reach code um, that we have in our smart contract. If it's not reaching the code, then we should know why and iterate over the result. Perhaps we are not setting up correctly all the things that the tool needs. So Echidna can dump the coverage in a file using corpusdir, the corpusdir parameter. In this case, Echidna will print all your smart contract code in a single file. It will paste together all the source code, and basically it will show what we call markers on the left side. A marker indicates when the tool can reach a certain line. And there are several types of markers, right? As you can see here, these are the asterisks and the arrow. There are several types of markers, and markers are independent of each other. So in this case, some lines are covered with one marker and some other lines are covered with two markers. The asterisk means that Echidna is able to reach that line, and the end of the transaction has not reverted. So it reached the ends of the function without reverting. And a marker with error means like Echidna reached that line, but at the end of the transaction it reverted. Right. And as I said, this is independent. In this case, there are two ways in the invariant. There are two ways to reach the line, basically because the assertion will force a revert. So it means like there are some the tool find a way to reach that line in a revert, in the context of a revert. All right. Okay. So that's the theory part of this presentation. So I think, and I wanted to add a more practical, interactive part in which we take a quick look into a code and try to write invariants and run very, very short fuzzing campaigns with the tool. So you can suggest what to do, you can ask questions. I don't know if Discord allows people to raise a hand like you can do in Google Meet. If you have a question or something in this section, please just use the microphone.
Yeah, does anyone have any questions? And then if we have multiple people that want to speak, they can just post the questions in audio Q&A, and we'll get to them. But if anyone wants to start it off, you can just come on voice right now and ask a question.
All right, yeah, and please tag me so I can see that there are questions or people waiting to talk will be useful. So I will give a short explanation, and we start with the interactive part. So so the first thing that you will need to install the tool. So we recommend to use supercompiled binaries, but you can compile if you want. There's the Docker option. Just make sure that you're using the latest release and make sure that you have Solidity installed, because it depends on that for certain things. So what we're going to do in this the rest of the presentation, we're going to take a quick look to a very small piece of code called SumDefi. This fictitious synthetic DeFi application will allow users to, given that it's deployed with certain the address of a RC20 contract, it allows to mint shares and withdraw shares, and also have another function called shares of, which will just return the number of shares of a user. So this has kind of a basic similar template or components of some DeFi applications that are much more complex. We're going to take a look to the code because it's really simple and you should not have any trouble to understand it. And we're going to write some tests with this. And how we're going to use the tool. So we're going to call Echidna test. The testing mode is going to be assertion. We're going to define to set the target contract as test SumDefi. We're going to see the code in some minutes. And we're going to use some config that I'm going to explain. And finally, the actual, where is the source code located? So Echidna will compile the code, deploy it, and start running the code. So I'm using Solidity 0.1, but you can use another version if you want. All right, so let's jump into the interactive demo. So I will start sharing another screen, but we'll be happy to take questions before starting with this. If you have some fundamental question that you want to start right now. So we'll switch the window. Yeah, I will be providing some link to the actual. In fact, I can provide it right now. Yeah, you can really go into the thing if you want. Right, yeah, let me share the screen here. See, screen. All right. So let me see. Can you see my screen? I think so.
I can see it.
Okay. So someone has the microphone open. I'm hearing a lot of noise. So please. Great. Okay. Let's take a look to what we have to test. SumDefi. All right. So is the code, is the screen large enough, or should I make it larger?
It's good to me.
Okay, great. So let's take a look to what we have for testing. So we have the SumDefi code here. And this is going to be an RC20 token that allows to mint shares, withdraw shares, and ask for shares. The first thing, so this is going to be, as I said, an RC20. I have some code that took from OpenZeppelin. It's simplified, so it's shorter here. To simulate an RC20 token, not only for this DeFi application, but also because it will allow to do transfer from and to do the minting of shares. So this is the RC20 token, RC20 code that you already know. The only difference is that we remove in the transfer from, we remove the allowance. It's not necessary to do it, but it's just going to make all the testing faster and easier to see. So we don't have to worry setting allowances and stuff. But definitely you can do with the original code. It will work as well. So this is the RC20 code that you know. So this is going to be an RC20 that starts with no shares at all, and it allows to mint shares. And when it mints shares, it will do the transfer from the sender with certain amount of tokens. And if the total supply is 0, it will mint the number of shares equal to the number. So it will mint 101 with shares. And if it's not the case, it will mint with certain in a certain way. So basically divided by the total supply and multiplied by some constant. And withdrawing shares similar. We're going to check that the number of shares that we have is enough. We're going to take the total supply, the old total supply, because we are going to do we are going to burn the shares, and we're going to divide. If the old total supply is equal to the shares that we are burning, we're going to return it 1-to-1. If it's not the case, then we're going to return it with this formula, which is kind of the inverse of the other one. If you're asking if this makes sense from the economic point of view, we don't really care about that in this simple code. And this is definitely a very simple and synthetic example. So please don't take it as the way you should be doing this. This is just for this presentation. So what we're going to do is we're going to create. So we create this test on DeFi contract that will initialize. So the first thing that we're going to do is we're going to initialize with a new RC20 token that allows to give tokens to the addresses that the Echidna will simulate. So Echidna will simulate a number of addresses as users or potential attackers as well. So in this case, we're going to take 2 of these addresses, and first we're going to create a new RC20 token, which is the one that we're going to use for deposit into the DeFi. And we're going to give them some tokens. If we don't give them some tokens, then they're not going to be able to mint any shares. And if you're not going to mint any shares, that means that you're not going to do any meaningful testing of this code. So the code that we have right here is a unit test. So basically, what we are going to do is we're going to require that this unit test start with total supply equal to 0. We're going to take the old balance, and we're going to make sure that the old balance is more than 1,000. We're going to mint 1,000 shares. We're going to assert that the share of the sender is equal to 1,000 because in the case of total supply equal to 0, we have 1-to-1 minting. And finally, we're going to check that the balance of the message sender was reduced by 1,000. Great. So this is a unit test for mint shares. I created another one for withdraw shares, but let's focus into this first. I'm going to so don't make this confusing. So okay, so the first thing that I'm going to ask is how. So yeah, let's test this before starting to something. This part. So we're going to run this, and Echidna will run with random inputs. It's interesting. We're using a fuzzer to run a unit test. The unit test should never change. So what is the point of running the fuzzer if you're using a unit test? It's not really useful, but we are doing it now so we have a starting point. So as you can see, there's no failures. Everything works fine. It's testing the assertion of every function. If it has assertions, it will test it. So the question is, how can we know this is working correctly? So one thing that we can do is we can comment this total supply requirement. So what will happen if you try to run this test if the total supply is positive? Well, the test should fail because this will no longer be the case, right? This thing here. So we're going to run this. We're going to see immediately. We see that if we call min shares and then we run our unit test, it's going to fail. Not only that, it will tell us what are the events that are triggered. These are triggered by the RC20 code. These are transfer. In the first case, it's so it will show you the events of the second of the last transaction. So it will try to mint with 1,000, but it will actually mint more than 1,000 shares. It will mint a lot of them. So this test is not correct. The unit test, we should improve this. Right. So the first question is there something in this unit test that we could improve before transforming this into a property? And I'm open for suggestions or questions from you.
What does everyone think?
Sorry?
I was just saying, if folks can speak up if they wanted to give feedback on that question.
Sure. So perhaps one hint here. Here in this line, we are assuming that the shares of the sender are 0. And if it's not the case, this will fail. So we already started to identify things in the unit test that are not general enough. They work, but they're not general enough. So that is one thing that perhaps we can think. So, but in any case, so how we can transform this into a property? How we can make this a little bit more generic in order to make to use a fuzzer. So the first thing that we're going to need a parameter. Not all tests, not all invariants need parameters. Sometimes the parameter, the state is carried over with the storage variables. So some unit fuzzing tests don't need any parameters, but in this case we need one. So we need to know the number of tokens that we want to use for this. So we are going to still require this total supply equal to 0. However, we are going to need to change this 1000 into something. Any suggestion?
Just unmuting mine. So reading through what Mint Shares does, it transfers from sender first. So the old balance would need to be greater than or equal to token.
Yes, that's a very good suggestion, and in fact, it will be one of the preconditions. So we can think preconditions as conditions that we need for this test. So the first precondition is total supply. We can note here. Total supply should be 0 in order for this test. The other precondition is user should have enough balance. We will change this assert into required because we're not going to assert that. All right.
It looks like you have, is it a typo there? So you in 256 tokens versus there's no S on it? Yeah.
Thank you. All right, so what else we need to change in this in order to transfer this into a more general?
I think similarly, everywhere you have 1,000, replace it with tokens.
Yes, so that's a good idea. So we can go and replace this. All right. Great. So it seems we cover this. And as I said, in this case, so yeah, let's test this. Okay, you can see it start running and it start exploring. So it seems that this is enough for this case, in which we assume that total supply is equal to 0. Great. So that was the first step. Wasn't so hard, right? I think it was pretty
Not too bad.
Yeah, great. So yeah, you can, as I said, we can document this as like preconditions and postcondition. We can do like this precondition, yeah, all balance should be enough. And then what are the post conditions here after min share? So we have, we can have the post conditions here. As I said, careful with this on a general case, because here we are assuming that the all shares of the sender are 0. And in this case, if we're going to do a more interesting testing, this is going to fail, because it will require to know what are the number of shares that we had when we start in order to compute the amount that is increased. All right. Okay, so we have, so is there, so let's go back into the code. Here, sure. Is there any other interesting property that you want to test, or you would like to test in this code in the main shares? Highlight.
Generally, the second half of the branching there, so the else, if total supply is greater than 0.
Yes, definitely. But let's say that we focus on the total supply equal to 0. Is there any other thing that we want to test that could be interesting? So the question is, when you call min shares, what do you expect? What the user should expect from calling to min share when total supply is 0? Besides these conditions, is there something missing?
Let me take a look. Yeah.
Perhaps I can give you, It's, so one thing that is very useful when you're doing this type of testing is it's called mutation testing. In mutation testing, you take the code that you have and you introduce a modification on the code. And one modification, and you check if your tests are passing or not. Let's introduce a small modification in min shares. In this case, I'm going to add this. So again, something, or again, let's say, let's say I take this, put revert. So let's check what's happening. So it seems like if we replace the min code by a revert, then no tests are failing. And this is something that we want to change. We want to be able to know if minting share reverts, because that could indicate that something wrong is in our code. So why this is reverting? So it's really simple. It's reverting because when we do the mint share, if it reverts, it's not going to, the post conditions are not going to fail because the actual execution will end. So what we can do to this? Well, we can do a try. We could do a try and catch. However, there are certain things to deal with this. So in order to do a try and catch, we need to do an external call. And this will require some changes in the way that we test, because the contract, the user calling the actual contract is going to be this contract. So it's going to be a little different to test. I'm not going to go into that right now, but be aware that you will need to make sure that the reverts are covered. In that case, we will need to refactor a little bit, because this, we are testing from the same contract. Now the user that should do the transfer from will be this contract, will be the testing contract, and some DeFi will be deployed in some other thing. So this is going to be different from the current setting that is deployed in some DeFi. So we're going to leave that as an exercise. So let's go over testing the other branch. If we
Just
want
before
just
you
to, yeah.
just before you move on, so if it were to revert, um, that would still show up in the reporting with the. Would it give any reason as to why it reverted or no?
Um,
When you were
so
showing the asterisks are line by line.
So it's not going to give you a reason. It's going to tell you it's just reverted. There are
Okay.
certain type of reverts that are marked as a different with an error. If you have a zero division, Solidity will put a special type of error, which is basically an assertion failure that we can easily catch. But we usually we can't show the revert reasons in the coverage because that will mean a lot of information and it will be difficult to show. But if you also have some ideas, some suggestions on how a feature could work that will show some there are reasons inside the code, please let us know. We'll be happy to discuss
Yeah.
any potential features.
So not so much a feature, but in terms of workflow, if I was going through creating tests like this, and then I ran it, if there was a scenario that the fuzzer could trigger a revert, it would show mint shares. Would it show that line was the one that caused the revert in
Yeah,
your test mint shares function?
yeah, we can test that.
Okay. Because then I guess just going through workflow, that would be the trigger to do better handling of the revert. And
Yes. Yes, exactly. Let's take a look to the corpus. So we have this. Yeah, let's see. So you can see here min shares and a revert ending inside in this revert. So that looks suspicious, right? And the execution is not reaching with the asterisks. Min share always reverts. That's something
right.
bad. Another thing that you can see is in the test, it's actually always reverting. No way to catch it. There's no way to go into the other ones. So that's another way to know that your tests are not good enough.
Okay. Yep. That helps quite a bit.
Okay, great. So another thing that we can do is to test the other branch. So let's do a very simple naive change here. So I'm going to revert this revert change. Yeah, already. To remove the corpus. Run it. And yeah. So in this case, calling test min shared. The first time will work fine, but the second one will fail. And we need to, so one thing that we can do, and this is actually recommended, to take copy and paste. We're going to leave this. I'm going to name this min share and total supply is 0. So we have test min share and total supply. All right. So we have here, we remove this. Yeah, sorry. In this case, we're going to assume that this is more than 0. So this is going to be positive. All right, and all balance. This is going to be the same. So the question is how we can fix, or what change we can do to fix this. So we're not going to go overall the property. However, I'm going to do a reduction. We are almost finishing, so we're not going to take much of your time. So we'll keep this short, and you can play this with the source code. We're going to do a simple test in which we're just going to test that. We are going to test a simple thing. We're going to test that if we are tokens is positive. So we're going to require tokens more than 0. And if tokens is more than 0, we are going to assume that the tokens that we get are going to be more than 0. So after we run this, after we call min shares, we should always have a positive amount of shares, which makes sense from the user perspective. If you send some tokens and you get back no shares, perhaps you will be wondering why you did that. So yeah, let's take a look to see if this works. So it seems like in certain cases, despite which we send a positive amount of shares, we get no shares at all. That's interesting. And perhaps that could be considered as a bug. If we go back to the code, we see that in this case there's a division. If this division is, if this number is less than this division will return 0, and you will get no shares at all. Sorry, here. Yeah, you will get no shares at all, and that is perhaps unexpected from the user's perspective. So yeah, one way will be to go back into the code and says and calculate the amount of shares here with the total supply, and then assert put as required here some requirement saying total shares int. So even if you call min 0, it will revert. You don't expect to have this. You don't want the user to waste any money minting no shares at all. So yeah, as just wanted to go back into the presentation to finish. I want to take too much into the hour. So let me stop here and reshare my screen. All right, so we have the interactive demo. So please feel free to continue with the testing of this very, very simple code using Echidna and exploring, testing different type of properties and checking the always explore, and if it's catching the bug that you expect or not. Consider when it's reverting or not, and perhaps optimize properties, merging them when they are similar. Like these two properties that we created, we can merge in a single one and have everything in one input. And finally, just one slide to remember that we are hiring. Happy to review your applications. We always looking for either security auditors, or we have the apprenticeship program in which we train. We have a 3-month intensive training in which you can shallow real audits and work with a senior engineer in order to use our tools, find issues, and write reports. So yeah, that's all I have for you. Sorry, I stepped a few minutes. Um, I think it's really really excited to show you that interactive demo, and I think it's something people ask when we give like purely theoretical presentation. They want to be able to see the workflow and see what are the type of things that you try, what are the type of things that work, and what are the type of things that you need to overcome. All right, yeah, happy to take any questions if you have them.
Yeah, are there any questions?
I have a couple if no one else wants to go first. So
Sure.
this is a good example. You had an ERC20 token as part of the demo contract, which a lot of contracts that would be auditing do have some form of ERC20 functionality or other ERC functionalities. Do you guys maintain a library of Echidna-based tests for common use cases? ERC20 is a common one, but even if you think of a lot of projects would fork Master Chef and then modify it, or fork synthetics and then modify it. Do you have an existing test suite that you would start with for anything that's derived from synthetics and then modify it to suit the need, or do you write new ones for each engagement?
So we usually write new ones, but we are definitely evaluating to have a set of standard ones, even if we don't use them every time. They're useful for introducing people and to have this approach in which you need like Uniswap, and then you have Uniswap deployed in a certain address, so you can start your test without actually having to mock to create models or mocks of stuff. So so we usually, when we don't, for things, for complex things like, let's say, compound or synthetics or things like that, we usually create a small model of what we need. Like for instance, you're calling a function that should return certain values. So we create a small piece of Solidity that we even allowed Echidna to set up some values, like oracles. Oracles are completely external. So we have we create these fake oracles in which Echidna can set the value before a transaction. So we have some we discovered some issues in some projects in which, for instance, um, a property will fail when the oracle reports a price and then it drops to a value near zero and then it returns to the same price. So we have certain pieces of code that allows to simulate oracles and to instrument them, but we don't have a standard library, let's say. It's something that we are definitely I think as a new feature in our testing.
And what would be the best place to stay up to date? So if you were to release it, would it just be follow the Trail of Bits Twitter account, or if you make that announcement so we don't miss it?
So we have the Twitter account. We have you can just subscribe to the GitHub repository, and you will get I think you will get an email when there is a new release, and perhaps nothing else you can just configure. And you can check on Discord. We don't have an official Discord. We have Slack. But definitely we can ping people here when there is a new Echidna release or Slater release or any other tool. We'll be happy to do it if it's relevant to the Spearbit community.
Well, yeah, definitely seems relevant. Another question about, so the fuzzing that it does, if I remember a Twitter conversation that I read not too long ago, if you were to compare it to something like the fuzzing that Foundry currently does, or some of the other tools out there. How does the Echidna fuzzing work, and what's special or novel about it compared to some of the other ones out there?
So yeah, there are a couple of things. So Foundry is a really interesting tool, and I think is perhaps without count Echidna one of the most advanced tools in terms of fuzzing. So Echidna is doing a similar fuzzing to Foundry. However, we have different ways to approach some of the things. We know that Foundry is still evolving. For instance, the way in which you test with Foundry is a little different. The way in which you define where a test fails in Foundry is a little different to Echidna in terms of when we report failures. We have a mode that emulates part of what Foundry does in terms of testing. So one common discussion in testing is how we can define a function in Solidity that allows to test, right? And if there is a revert, are we going to count this revert as a failure or not? So these are the type of things that are different from the Foundry approach. Also, Foundry, I think, still working on the invariant testing. So again, it has two modes. It has a stateless mode in which you run with a single transaction and you reset the state of the chain every time. And you have a stateful mode, which is what I show you, in which you have different transactions. I think, so I need to check the latest Foundry development. I think Foundry is still working on the stateful mode, and perhaps someone can correct me if there's someone from the Foundry development team here. I think they still have a PR for that. Foundry also is still working on the coverage, showing the coverage. I think they also have a PR. So I think Echidna is a more mature project right now for doing the testing. On the opposite side, Foundry is more aimed to have a complete framework of development. We don't aim to have a complete development framework. You can use Echidna with Hardhat or even with Foundry itself or with Truffle. So that's also different a tool like Foundry. And also we have a little bit more work on the testing with dictionaries and collecting. And I know Foundry is still working on that features. So yeah, so there are certain cases in which tools are not going to behave in the same way.
Well, yeah, the modes sounds quite interesting too. The stateful multi-transaction mode.
Yes, this is enabled by default. And I think by default, Foundry will do stateless mode. So if you want to do stateful testing with Foundry, you will need to have an input as a sequence of things, as a sequence of, let's say, operation. It's kind of annoying in some cases, most of the cases, or it's different from the Echidna approach.
Well, thanks for the introduction. This is very useful. I was talking to Natalie from Trail of Bits, and she says she uses it quite a bit, and I've read some of her audits, and Echidna is one of the tools that I've been meaning to learn and haven't had a chance to. So this is a great introduction.
Great, yeah, happy to. Yeah, if you don't have more questions, happy to take any questions offline. I don't know which is the best channel for that. I mean, you can always send me a DM, but probably it's better to have the discussion public so other people can see them. Which is the best channel in the Spearbit Discord for that?
Good question. Spencer, do you know?
Yeah, just do it in general, honestly.
Oh, okay.
Yeah.
Okay, great. All right. Yeah, I can provide a PDF of the slides if people people want them to review them. And also with the link to the code, so you can play at home. Yeah, happy to take any other questions offline. And when you have the recording, please ping me so I can refer it to some other people.
Any other questions?
None for me. This is great. Anyone else?
Thank you. Thank you. I0001 is typing in the Spearbit 2 chat. Let's see what he says. Oh, thank you. Cool. We'll wait for like 5 more seconds if anyone has any last minute questions. Going once, going twice. Sold. Gustavo, thank you very, very much for stopping by today. We're really grateful.
All right, thanks for the invitation, and yeah, as I said, happy to take any offline questions on the Discord.
Cool beans. Yeah, I think if you don't mind sticking around for like a minute, maybe an audio Q&A if people have any async questions. But otherwise, thanks again, Gustavo.
Okay.
Thanks to the community for the questions, and everyone have a great Wednesday. Thanks.
Thank you. Bye-bye.
Bye. Thank you.